Energy, specifically having a plentiful supply of it, is one of the most basic requirements for modern civilization. We depend on it for transportation, personal comfort, industrial and agricultural production, entertainment, and a host of other necessities and conveniences. In recent years, though, energy production and distribution has attracted a lot of public attention, partly because of the massive economic and geopolitical impact of the industry, and partly because of its perceived negative impact on the environment. Energy efficiency, in contrast, tends to fly under the radar. In this short talk, I will present an overview of the application of energy efficiency principles specifically within the process industries. There are additional materials within the AICHE Academy that provide a more detailed treatment of this topic. Energy efficiency is not simply about reducing the amount of energy that we use. After all, we can minimize energy use by shutting down our refineries and chemical plants and eliminating production, and that's clearly not our goal. Rather, for an industrial operation, we can define energy efficiency as the reduction of energy consumption subject to production requirements, safety and environmental considerations, and other legal, economic, or practical constraints. Energy efficiency is important in the process industries for several reasons. These include, first of all, the general desire to make production sustainable. In many facilities also, notably in oil refining and large-scale petrochemicals, energy is a major cost, and energy efficiency is an essential component of competitiveness. In some jurisdictions, energy efficiency is mandated under law, and some companies also use low energy consumption and reduced environmental impact as key components of their brand identity and marketing strategy. Many companies in the process industries have developed and executed very successful energy management programs. For example, ExxonMobil's Global Energy Management System, or GEMS, started in the year 2000. In their 2009 annual report, the company announced that the program had identified energy savings opportunities of between 15 and 20% at its manufacturing sites, and had captured over 60% of these savings. While 15 to 20% may not sound like much, it can amount to billions of dollars in large refining and petrochemicals companies. It's not easy to achieve improvements like these in companies where energy has already received a great deal of attention in the past, and many of the easy opportunities have already been captured. There are also several programs and systems available to industry from other organizations. For example, the International Organization for Standardization launched its energy management standard, ISO 50001, in 2011. It has been adopted by many companies around the world, most notably in Europe, where some governments offer tax incentives to companies that are certified to the standard. ISO 50001 is also actively promoted by the U.S. Department of Energy. United States Environmental Protection Agency's Energy Star program also provides a pathway for companies to manage energy, and it is used widely, especially in the U.S. There are also numerous software and consulting organizations engaged in various aspects of energy efficiency and energy management. Most industrial energy efficiency programs include some or all of the following elements. First, securing senior executive level sponsorship, establishing an energy team, developing an energy policy, collecting and reporting data on energy use, benchmarking energy performance, prioritizing opportunities for improvement in energy efficiency, developing and executing action plans, implementing projects and operating improvements to save energy in existing facilities, ensuring that new facilities are energy efficient, monitoring performance and verifying savings, recognizing and communicating successes, and finally working towards continuous improvement. Energy management programs or systems provide a framework within which energy efficiency can be pursued and sustained. However, the system itself does not create the savings. Energy efficiency can only get better when processes and behaviors improve. Changing an industrial process typically requires a significant monetary investment in equipment, piping, and control systems. It can be hard to justify this type of investment within an existing plant, especially in regions where energy costs are low. However, the economics are often significantly better when enhanced energy efficiency options are incorporated in new facilities or in revamps that are driven primarily by debottlenecking or yield improvements. In some cases, the total investment in a facility can actually be reduced as its efficiency increases. One striking example of this is a refinery crude expansion project that was carried out a number of years ago. The initial plan included a new charge furnace with a hot oil belt to provide heat for the additional feed to the atmospheric crude column. A pinch analysis was carried out to see if a lower energy option could be found. This resulted in a modified crude preheat train design downstream of the desalter, and this achieved the required energy input without the large investment and increased energy usage associated with the new furnace and hot oil belt. Energy efficiency should always be considered closely in all major projects. In contrast, changing behaviors either of individuals or organizations is often a low-cost or even zero-cost activity, as it usually involves only redirecting or altering the priorities of existing personnel. This can be as simple as reminding people to turn the lights out when they leave a room, although in a process facility, the required changes are often more complex. Many process plants are operated suboptimally, and it is important to secure the greatest benefit from existing equipment before pursuing investments in new facilities. Often, all that is needed is simple operating changes. A common inefficiency in refineries and chemical plants is the unnecessary cooling of process streams that should be kept hot. The sketch shows an example of this from a study at a petrochemical plant. The design of the distillation column includes an air-fin cooler on the feed. This was installed to prevent overloading of the overhead condenser under certain abnormal operating conditions. However, the operators ran the air cooler continuously during normal operations too. This removed heat from the feed to the column, which in turn increased the heat load on the reboiler. As a result of the study, the procedures were changed and the air cooler was shut off during normal operation. This reduced the reboiler duty by more than 30%, a saving worth more than $1 million a year at no cost to the facility. Within the wide range of sectors in the process industries, there are a great diversity of operations, ranging from world-scale refineries and petrochemical facilities that have annual energy bills in the hundreds of millions or even billions of dollars, to smaller, more specialized facilities where annual energy bills can be in the order of $1 million or less. Larger scale operations tend to be continuous, but most smaller volume processes operate in batches. Some equipment and systems, such as electric motors, heat exchangers, pumps, compressors, and steam systems, are found across a wide range of sectors, but many processes also use highly specialized equipment. In many of the smaller facilities, lighting and space heating and cooling are the dominant energy users, but these are just a tiny percentage of the total energy spend at large petrochemical sites. It follows that there is no one-size-fits-all approach to identifying and implementing energy management programs and efficiency improvements. However, there are several types of activities that have proven effective at finding energy savings within the industry. An energy manager can choose which ones are the best fits for his or her situation. These activities include site audits and assessments, process flow diagram reviews, heat integration, often using pinch analysis, focused maintenance for energy-critical equipment such as heat exchangers, steam traps, and steam leaks, steam system modeling and optimization, energy efficiency workshops for capital projects, performance monitoring and key performance indicators or KPIs, and employee suggestion programs. I trust this overview has been helpful. Please explore the other materials available within the AICHE Academy for further guidance on energy management and opportunities to improve energy efficiency.